Hey everyone. Well, I hope you watched the first video because with the second video, we're kind of jumping into things. I, uh, it's interesting how circumstance sometimes works. So, I have a problem today that I want to start with that has square root of x equals y, and it has y equals x minus 2, and I want to find this region. Um, This point here is, of course, the x-intercept of 2, and this point here is 4, 2. Okay, so how do we, let's fix that. How do we do this problem? Um, we, uh, we can't use top minus bottom without breaking this up. Because look, over here, this curve is top and this curve is bottom. And so we're tempted to say something like the integral from 0 to 4 of square root of x minus x minus 2 dx. But look over here. Is this that curve? No, we'd be integrating down here if we were going to do this integral. This integral takes us all the way over here, and that's not my area. I guess you could say, well, this shape here is a triangle. And so you could find that integral and subtract from it the integral from 0 to 2 of, now you can use top minus bottom, because this is the top and this is the bottom. So 0 minus x minus 2 dx. But that to me is a big pain in the butt. My gosh, why would you do that? 0 to 4 square root of x minus x plus 2 dx. Minus a minus is plus the integral x minus 2 dx from 0 to 2. Okay, so that's going to be x to the 3/2, 2/3 minus x squared over 2 plus 2x from 0 to 4, which is going to be square root of 4 is 2, 2 to the third is 8, 8 times 2 is 16/3, 4 squared is 16 divided by 2 is 8 plus 8. So I get 16/3 from the first integral, plus x squared over 2 minus 2x from 0 to 2, 4 minus, what? That area is 0? That area is not 0. What's wrong with this? That's kind of freaky. I don't know what to make of that. Did I integrate wrong? That's the curve x minus 2, x squared over 2 minus 2x from here to here. I mean, I know the area of this is 1/2 2 times negative 2. So 4, 2, that's negative 2. Why didn't that give me negative 2? Oh, because 2 squared is 4. 4 divided by 2 is 2 minus 4. Isn't thinking great? Okay, so we've got 16/3 minus 2, so minus 6/3 is 10/3. Okay, well, that was a painful way to do the problem. Let's try another way. Same problem. Oh, not that one. That and that. There's our region. 2, 4, 2 equals x minus 2, y equals square root of x. Now, I could, of course, find each of those regions. The first region is simply enough. Integral from 0 to 2 square root of x dx. But what about region 2? Well, for region 2, I have to go from 2 to 4 of top minus bottom. Okay, top minus bottom is going to be square root of x minus 2 dx. Okay, so if this is correct, then we should also get 10/3. We saw 10/3 was the answer the last time we did the problem. Let's check it out this time. So we get 2/3 x to the 3/2 from 0 to 2 plus 2/3 x to the 3/2 minus x squared over 2 plus 2x from 2 to 4. I plug a 2 in, I get 2 to the 2/3 times 2. Ew. 2 to the 2/3 times 2 over 3. Well, yeah, that's 2 to the 1, so that's 3/3 plus 2/3. That's 2 to the 5/3. I'm not liking this, are you? Okay, and then over here, we plug in a 4. We get square root of 4 is 2, 2 to the 3rd is 8, 8 times 2 is 16/3, minus 16 divided by 2 is 8, 4 times 2 is 8, minus, now we plug in a 2, and we get that 2 to the 5/3 again, over 3, minus 2 squared is 4, 4 divided by 2 is 2, and 2 times 2 is 4. Okay, so these cancel. We get 16/3. Don't forget the 2 to the 5/3 over 3 out here. Then we distribute this negative. We've got, I guess we could combine like terms and make 2 there. We distribute the negative, and we get minus 2 to the 5/3 minus 2. Well, the 2 to the 5/3 over 3's cancel, and we have 16 minus 2, or 6/3, and we end up with 10/3. So that's another way of doing this problem. But wait, there's more. We could, of course, do the problem since I'm looking for this region. We could integrate just square root of x but that includes all this extra stuff here that we have to take away. So I'm proposing a third approach, square root of x from 0 to 4 minus the area of that triangle. And the area of that triangle is integral from 2 to 4 of x minus 2 dx. Or you could say integral square root of x dx minus the area of that triangle from 0 to 4. So we're going to get 2/3 x to the 3/2 from 0 to 4 minus x squared over 2 plus 2x from 2 to 4. So I plug in a 4. Square root of 4 is 2. 2 to the 3rd is 8. 8 times 2 is 16/3. And then here I plug in a 4. 16 divided by 2 is 8. I plug in a 4. 2 times 4 is 8. Minus 2 squared is 4. 4 divided by 2 is 2. This is minus 2. 2 times 2 is 4. Watch your SIGNs here. These cancel. This gives me 2, negative 2, 16 thirds minus 2, or 10 thirds again. Or you could find the area of that square root, that's this problem here, and subtract the area of the triangle. 1/2 a height of, what's this height? Well, if this is 4, 2, the height is 2. And the base goes from 4 to 2. So these cancel, and I get 4 minus 2 is 2. So I get this 16 thirds minus 2 again. Okay. But in fact, I actually want to show you this last way. This last way, I think, is certainly worth doing, or at least worth considering, because it only involves one integral. This is the area that I'm looking for. And here we have 2. Here we have 4, 2. This is y equals square root of x. And this is y equals x minus 2. All right, but this time when I do the problem, I don't want to think vertically. Because look, I have this, which is constant, and I have this, which is constant across my integral. So instead of doing top minus bottom that had one top here and this bottom, and the same top but a different bottom, I plan on doing right minus left. Now, when you integrate right minus left, instead of y equals functions, you need x equals. So solve this equation for x by adding 2 to both sides. And over here, solve this equation for x by squaring both sides. Okay, so now we're going to integrate right, which is y plus 2, minus left, what was this curve, y squared. And now remember, since we're going and integrating this way, we're integrating dy's. These are dy slices. Notice if I extended them, we would measure their thickness on the y-axis. So this is a dy, and I need y bounds. So when I integrate here, I get y squared over 2 plus 2y minus y to the third over 3 from 0 to 2. 2 squared is 4. 4 divided by 2 is 2. 2 times 2 is 4. 2 to the third is 8 thirds. So I've got 6 or 18 thirds minus 8 thirds is 10 thirds. Now, ultimately, I don't really care which of these different ways you use to find this area of this region. What I'm saying, though, is problems like this frequently show up on our tests and on the AP exam, and sometimes I've seen, say on a CFA, students get terribly, terribly confused trying to do it. So my recommendation might be, if you're having difficulty discerning top minus bottom, and then integrating, you might want to do right minus left. That might be helpful. Okay, I just wanted to do some practice problems with you today that maybe practiced right minus left a little more. Let's take a look at some of those. I also had in mind maybe 1 or 2 calculator problems, and maybe 1 or 2 people make common mistakes on these problems. So let's start with this one. Y equals x, y equals 2, and x equals 0. You know, it's curious. The challenge with this is that people treat this like that. So the issue here is y equals 2, y equals x, and x equals 0. We're looking for this integral here. You know the height is 2. Where does y equals x intersect y equals 2? when x equals 2. So this is the point 2, 2. And so you know this distance is 2, and you can do 1/2, 2 times 2. That's fine. That's the area of a triangle. You know, it might be nicer if you did a top minus bottom, 2 minus x dx. And you're integrating x's, so you're going from here to here, so 0 to 2. And you get 2x minus x squared over 2 from 0 to 2, which is 4 minus 2 or 2. Okay, same answer. No problem. The issue here, as I said, is people graph this funny. I don't quite know yet why that is. Maybe some people will make more mistakes with that this year. All right, let's take a look at this one. Y equals sine x, y equals e to the x. So, yeah, exponential growth. And sine x, we know this is the point 0, 1. And we know sine looks like this. And Mr. Kukla, they don't intersect. I know. That's because I'm interested in the area between the curves from 0 to pi over 2. So here's 0. Here's pi over 2. And I like top minus bottom for this. The integral of e to the x minus sine x dx from 0 to pi over 2. Well, that's e to the x plus cosine x from 0 to pi over 2. Don't forget to plug the 0 in, because e to the 0 is 1, and a lot of times people forget to plug the 0 in. They forget to plug the 0 into cosine, and oh, they forgot to get that 1, because cosine of 0 is 1. So I get e to the pi over 2 plus cosine of pi over 2 is 0 minus e to the 0 plus cosine of 0. Well, that's pi over 2 minus e to the 0 is 1, cosine of 0 is 1, so I get pi over 2 minus 2. Now, I have a problem with that. And my problem with that is the fact that pi over 2 is about 1.57, and 2 is bigger than that. And so when I do this subtraction, I'm going to get a negative number. But I can see the value of the integral here. So what's happening? What's my issue? I thought the derivative of cosine was negative sine. And I thought that the derivative of e to the x was e to the x. Oh, I see what my issue is. This is e to the pi over 2. Oh, e to the pi over 2 is much bigger. E to the pi over 2, 4.81. That's definitely bigger than 2. Okay, so there's my answer, and it's not a calculator question. I would like to go back for a second and look at this one. You know, we were talking about right minus left a moment ago, and I want to look at this problem again and ask you the question, would you want to do it as a right minus left problem? Why or why not? And my answer is, oh my God, no, because the right is this curve, and the left appears to be e to the x until it's not e to the x, it's this other constant. But then my right function, or my right curve, changes, and my left stays the same. So I would need 3 different integrals to do this as right minus left. So I think what I can tell you is that an easy right minus left will be a very hard top minus bottom, or a very so let me start again. An easy top minus bottom is a hard right minus left, but a hard top minus bottom is an easy right minus left. Okay. How about this one? X equals 1 minus y squared. X equals y squared minus 1. All right. I would imagine this to be on the non-calculator portion, which is fine because most people say, I don't know how to graph that. And the second thing I would say is when you see x equals, you're being set up to use right minus left. So let's take a look at what this looks like. We have y squared minus 1. And we have 1 minus y squared. That's supposed to intersect over here. And I don't have an undo button like I do on the smartboard. There we go. So I don't want to do top minus bottom because this is the same curve as this, and this is the same curve as this. I do want to do right minus left. So this one was the right one. This is the right, this is the left. Okay, so I'm going to integrate 1 minus y squared minus y squared minus 1 dy. Ooh, from here to here, I'm going to need to find those points of intersection. I need to find where 1 minus y squared intersects y squared minus 1. So I get 2 equals 2y squared, 1 equals y squared, y equals plus and minus 1. So there's negative 1, there's positive 1, and that's where I'm integrating. And so here I'm integrating negative 1 to 1 of 2 minus 2y squared. What about symmetry? Well, you know, I see that this region down here and the region above the x-axis are the same. So I think I'm only going to do one of them and double that amount. I think that'll be a much better use of my time. Okay? So we're going to have 2y minus 2y to the third over 3 from 0 to 1. And don't forget, all of that is times 2. So I plug in my 1 and I get 2 times 2 minus 2/3. 0, nothing happens. So 6/3 minus 2/3 is 4/3 times 2, or 8/3 is my area here. Okay, so that's how I would do that problem. How about this one? Y equals cosine x, y equals secant squared x on negative pi over 4 to pi over 4. Okay, well, it's interesting because I know that cosine and secant touch at a point. I wonder where that point is. Let's graph and see if we can find out. Okay, cosine. Cosine starts high, goes low. Actually, goes low at pi over 2 to the midline. And back here, negative pi over 2. I guess I'm supposed to take that further. Okay, so pi over 4s would be here. And then what about secant squared? Well, at 0, if I plug in a 0 here, that's secant of 0, which is 1 over cosine of 0 squared, which is 1 over 1, or 1. So secant squared comes down here and goes up. And we're integrating from negative pi over 4 to positive pi over 4. So this is our integral. Well, that's symmetry if I ever saw it. So I'm just going to do 2 times secant squared x minus cosine x dx from 0 to not pi over 2, but to pi over 4. Okay, the antiderivative of secant squared is tangent. The antiderivative of minus cosine is minus sine from 0 to pi over 4. And don't forget, all of that will be multiplied by 2. Okay, tangent of pi over 4 is 1. Sine of pi over 4 is root 2 over 2. Tangent of 0 is 0. Sine of 0 is 0 times 2. So I end up with 2, 1 minus root 2 over 2. And yeah, no, I'm not going to make a common denominator there, and I'm not going to distribute the 2. I'm just going to leave it like that. You're more than welcome to distribute the 2 if you want. That would give you 2 minus root 2. There's nothing wrong with that answer. And right now the sun is getting in my eyes, so I'm going to take a moment to adjust these blinds, I hope. All right. Let's do a few more problems, and then we can call it a day. Which one did I want to do next? How about y equals x squared, y equals square root of x on 1/4 to 1. Square root of x, y equals x squared. They intersect at 1, 1, but I'm not starting at 0. I'm starting at 1/4. Okay, so what do you think? Top minus bottom, right minus left. You want to split it into a couple of pieces. This is the region we're looking for. I'm not keen on right minus left because while up here I've got a right and I've got a left, when I get down here I still have the same right, but now I have a different left. So I would much prefer to do the integral from 1/4 to 1 of top minus bottom, square root of x minus x squared dx. And that gives me x to the 1/2, no, 3/2, 2/3, minus x to the 3rd over 3 from 1/4 to 1. And you might say, well, Mr. Google, why are you doing this problem? This problem doesn't seem very hard. It's a pretty straightforward integral. Well, there's two things I noticed that happen with this. One is, even though people are thinking top minus bottom, they switch these twos because this one has a higher power than that one. I don't know what it is about human psychology that does that, but watch out for that. And the second thing is plugging in this 1/2, this 1/4. Plugging in the 1 is no problem because 1 to the 3/2 is 1 and 1 to the 3rd is 1, and so you end up with 2/3 minus 1/3. But when it comes time to plug in this 1/4, the square root of 1/4, well, that's the square root of 1 over the square root of 4, which is 1/2. And you think, well, that's obvious, Mr. Kugler. Yes, but I will tell you, that a lot of times when people do the square root of 1/4, they write this number. So square root of 1/4 is 1/2. So we've got 1/2 to the 3rd, which is 1/8. 1/8 times 2/3 is going to be 4, 1/12. Okay, and then we plug our 1/4 in here. 1/4 to the 3rd is 1/64 times 3 in that denominator, which is 1 over 192. Now we're all smart enough at this point to know we're going to stop here because AP is okay with that. Otherwise, we'd have to make that common denominator with 190 seconds. And I don't really want to do that now. So we're moving on. How about this one? X equals sine y, x equals 0, y equals pi over 4, y equals 3 pi over 4. So yeah, about that. That's not inverse sine. That's x equals sine y. So x equals sine y is this graph. But we're only going we know that this would be pi over 2, and this would be negative pi over 2 from graphing sine. So we're only going here. And you might say, Mr. Kukla, how come it's not here? Well, remember we're told we're bounded by x equals 0. And this region here. No, not that far, Mr. Kukla. We're only going to pi over 4. You're stopping at negative pi over 4. Okay, well, these are the same because of symmetry, so I'm going to just say 2 times the integral. Wait a minute. Is that top minus bottom? Yeah, do you want to do top minus bottom? Look, they set it up as x equals. Shouldn't we be doing right minus left? Oh, I like right minus left, because that's sine y minus 0 dy from y bounds. Oh, I've got y bounds. Oh no, Mr. Kukla, you're such a numbskull. You were supposed to go to 3 pi over 4 from pi over 4, not negative pi over 4. Well, no matter. Pi over 4. I wish one of you had said something, though. 3 pi over 4. Okay, so the antiderivative of sine is negative cosine. Yes, yes it is. Of y from pi over 4 to 3 pi over 4. And don't forget that, times 2. So 3 pi over 4, negative cosine 3 pi over 4 minus negative cosine pi over 4. Okay, so cosine of 3 pi over 4 is negative root 2 over 2 times negative is positive root 2 over 2. And these will cancel. But that 2 has to go everywhere. So I'm going to hold off on that exuberance for a second and just say root 2 over 2. Cosine of pi over 4 is root 2 over 2. Minus a minus is plus. And so then I distribute and cancel both of those. And I get one of them plus one of them is 2 root 2's. And so there's my answer. I definitely don't want to do this as top minus bottom. Oh my god, look how horrible that would be. I have these constants, and then this is its own top and bottom. Ugh, no. No, 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 no. Okay, last problem I want to look at with you today is this one. Y equals negative x squared plus x plus 2. And y equals negative x to the third plus 4x squared minus x minus 6. Okay? And, you know, I feel comfortable factoring x squared minus x minus 2 as x plus 1 x minus 2. But what about this one? That's not going to factor with difference, with grouping. Since most of you completely rebel at the thought of using p's over q's, I'm going to say I think we need to graph this. Oh, I can get enough light on this. Maybe, kind of, I don't know. All right, I'll graph it on my calculator for you, but then I'm going to go back to doing it by hand. I see x-intercepts at -1, +2, and +3. I'm just going to confirm that using my table by plugging in a -1, a +2, and a +3, and I get zeros for all of them, so I'm not just guessing. Remember, there's a negative out in front, so my graph goes down like this, and then back up, and then back down. Okay, Now, what about this other graph, this down-pointing parabola we have? It's got intercepts at -1 also, and at +2 also, and it looks like this. Okay, and so here's what people do with this problem. They say, Mr. Kukla, no problem. It's not got symmetry. Kind of looks like it does, but it doesn't. But this is an easy top minus bottom problem. And the top problem is the down-pointing parabola, and that's a little weird because I always expect the higher degree polynomial to be on top, but it isn't. So don't worry, we're going to do this, and then we're going to subtract the bottom function, which is minus x to the third plus 4x squared minus x minus 6 dx, and we're integrating from -1 to 2, and it all feels great. And then I have to tell you, this isn't it. We've missed something. So what we missed was this isn't that steep. And this comes down here. And then there's a whole second region. So no, really, even on a calculator problem, you need to pay close attention and look at this stuff carefully. There's two integrals. There's certainly the integral from -1 to 2. This is definitely this. There's nothing wrong with that statement that we made. It's just that we left out this entire piece over here. Where's that? Well, if I pull out my calculator and do second calculate intersect and bring my calculator close to that point of intersection and hit enter 3 times, 4, -10. So plus the integral from 2 to 4. Now which function is on top? It's the other one on top. -x to the third plus 4x squared minus x minus 6 minus -x squared plus x plus 2 dx. Cautionary tale. Watch out for that, people. Okay, that's the end of day 2. I hope this was helpful. We'll have one day to tidy things up tomorrow, and I hope it all goes well for us. Okay, bye-bye.